This video will cover section 7.5, division properties of exponents. In the last video, we looked at multiplication properties of exponents, so now we're going to look at when you divide. So just like in the last video, we're going to start off with simplifying with writing everything out and seeing how things simplify down. Then we're going to look at the rules behind them. So if I have x to the fifth over x squared, in the numerator we're going to write 5x's for x to the fifth, and then in the denominator we'll write 2x's for x squared. And so what we did before is we could cancel out 1x in the top. For every 1 in the top, we cancel out 1 in the bottom, and we do that until we have no more to cancel out. So in this example, we have 2 in the top canceled out with the 2 in the bottom, leaving us with 3 in the top. So that's going to be x cubed. So the same thing as when you multiply like bases. Remember, with multiplication, you added the exponents, but look now with division. If I have 5 and 2, and that makes 3, so what happens is when I divide like bases, we're going to be subtracting those exponents, and so that's the rule for division. All right, so we'll look at one more example, and then we'll write out the rules. So for this example, see that we have different bases, x over y, as in the first one we had the same base. But you see this fraction, x over y, is raised to the fourth power. So if we wrote this out like before, we would have x over y times x over y 4 times. And then you can see in the numerator you'll have x to the fourth, and then in the denominator you have y to the fourth. So this one's very simple to see. It's just like if I have a product raised to an exponent, you distribute that. It's the same thing here. I have a quotient to an exponent, so both the top and the bottom get that exponent. So now we're just going to write those as rules. So if you have here a quotient and they have the same base, just like before when we were multiplying, make sure that these have the same base. Here our base is a. In the numerator you have a to the m, and in the denominator is a to the n. So if I divide same bases, then you subtract their exponents. So that would be a to the m minus n. So subtract exponents. And for the second example, we have a fraction. They're different numbers, and then those are both raised to the nth power. So what you're going to do is distribute that n. So we have a to the nth power divided by b to the nth power. So again, let's write that out. Quotient to an exponent. Then the exponent gets distributed. Okay, so same thing that we did before. I want you to go ahead and highlight a nice box around those rules so that they really pop out to you, because these are the things that you need to memorize. And next we're just going to work with some examples with quotients, and it's pretty simple. Okay, so for our first example, we have 8c cubed divided by 2c to the fifth. What you want to look for are like bases on top of each other. So if you see, we have the coefficients 8 and 2. And that really, since those are coefficients, they're not exponents, we're simply going to just divide them like we normally would. So 8 divided by 2, you're just going to get 4. And think of this as a fraction. So if you got 4, it's 4 over 1. So think of 4 as if it's in the numerator. So I'm going to put it like up on the top. And then we have the like bases of the c's. So in the numerator we have c cubed. In the denominator we have c to the fifth. So our rule says if we have same bases in the numerator and the denominator, then we subtract their exponents. So we subtract the top minus the bottom. So 3 minus 5 here is c to the negative 2. All right, so make sure you subtract top minus bottom. Now, this actually is not simplified because we cannot have negative exponents to be simplified. And we talked about that at the very beginning of this unit. Remember, for a negative exponent to be simplified, it has to move down to the bottom. And notice here that the 4 does not have an exponent of negative 2. So the 4 actually is going to stay in the numerator, and then c squared when it becomes positive, is going to move down to the bottom and become positive. So my final answer is c squared. Sorry, that's 4 over c squared. Okay, so for this example, this is, you have two different bases in the numerator and the denominator. So it's a quotient that is raised to another power. So what happens is we get that exponent outside the parentheses gets distributed to both the top and the bottom. So I'm going to kind of write a middle step here. So if x to the fourth, I'm going to kind of separate that quotient inside with parentheses. So x to the fourth gets a cubed, and in the denominator we have y to the fifth gets a cubed. And so then we apply our rule that we learned in the last video, in that x to the fourth cubed, that's a power to a power. So what happens there is they multiply together. So that's x to the 12th, and in the denominator, 5 times 3 gets multiplied to get y to the 15th. Now I cannot do anything further because x and y are different bases, so this is our final answer. For our third example, we have 6x cubed divided by 3x to the 8th, and then all of that to the negative 2 power. So we have a lot of things going on here. So inside the parentheses, if you look, you have x and x are the same base. And we're going to apply our PEMDAS principles here. So we're going to take care of what's in the parentheses first, since it can be simplified, and then we'll take care of the exponent on the outside at the end. So the first thing we're going to do is we're going to simplify, and we have 6 divided by 3. Those are big numbers. Those are coefficients. So those are simply just going to divide. So in parentheses, 6 divided by 3 is 2. So 2 is like over 1. So I'm going to put 2 in the top. All right, and then we have x cubed divided by x to the 8th. So just like the first example, we have same bases, and then their exponents are going to subtract. So top minus bottom, if you have 3 minus 8, that is negative 5. So that's x to the negative 5. Okay, so then that whole thing is being raised to the negative 2 power. Now you could do a couple of things here. You could actually, if you wanted to, you could have written 2 and then notice that x to the negative 5. We want that to be positive, so that could also have been written as 2 over x to the 5 to the negative 2 power. So really either one of those would work, but we're not quite done yet. Okay, so now either way that you have written this example, we can now distribute the negative 2 exponent on the outside. So on the top one, we have a product raised to an exponent, and in the bottom we have a fraction raised to an exponent. And either way, we're just going to distribute that exponent to both, okay? Like that. All right, so that's going to be, for the first example, we have 2 to the negative 2 times x to the negative 5th to the negative 2. Then 2 to the negative 2, remember our negative exponent rules? That's going to be 1 over 2 squared, which is 1 over 4. And then for the x to the negative 5th times the negative 2, you actually see what happens is the negatives, when they get multiplied, become a positive. So that actually takes care of it for us. So negative 5 times negative 2 is x to the 10th power. So then that x to the 10th is in the numerator with the 4 in the denominator. So that's one way of doing it. If I had gone down and I had my fraction, the 2 over x to the 5th, and actually I have up here that I was going to distribute, but I want to go back and revisit another rule really quickly instead of doing that. So if I go back to this, what that says is if you have a fraction that's raised to a negative exponent, what we learned at the very beginning is what you can actually do, the negative will make what's in the top move to the bottom and the bottom move to the top. So you could actually write this next and then to the positive 2 power. Then you could distribute, because we have a quotient, you could distribute the exponent. I actually think I like that way the best, but I just wanted to show you there are more than one way to get the final answer. So that's x to the 5th and then squared, so that's a power to a power, so 5 times 2 is 10. And in the denominator, that's 2 squared, so you get 4, which is the same thing that we got going the other route. Okay? For our next example, we're going to now have the variables inside the exponent, so expressions instead of just numbers. Notice first that you have different bases. So x and y are not alike, so you cannot do anything inside the parentheses to simplify. You can't subtract their exponents because they're not like bases. So what you have is the exponent 3, which gets distributed to both the top and the bottom. So I'm going to rewrite this in a separate step before I go to the final thing. So that's x to the a minus 2. That whole thing gets cubed. And in the bottom, y to the 2a plus 7, and that whole thing gets cubed. So now you see in the top we have a power to a power, and also in the bottom we have a power to a power. So that means that we're going to multiply those exponents together. So just to kind of show you, I put my a minus 2 in parentheses because that 3 is going to have to distribute. So then for my final answer in the numerator, we get x, a minus 2 times 3. 3 times a is 3a, minus 2 times 3 is 6. In the denominator, we're going to do the same thing. We have a power to a power, so we get to multiply. And watch out, that 2a plus 7, you need to think of that as in parentheses. So 3 times 2a plus 3 times 7. So that final answer will be y, 2a times 3 is 6a, plus 7 times 3 is 21. And again, you notice that I have different bases on the top and the bottom, so you cannot do anything with those exponents, and that is my final answer. We're going to do one final example, and then we're done. Okay, so notice for this example, unlike number 4, we actually have same base in the top and the bottom. So when you have the same base in a quotient, you're going to subtract their exponents. All right, now I'm going to rewrite this first before I start subtracting, and I want to show you why. So it's top minus bottom, so it's 4a minus 2 minus a minus 7. And I hope you see right now my mistake. Because if I wrote this like that, what's happening, what my mistake is I'm not fully distributing that negative. So really what I need to do is 4a minus 2, that stands alone, and then minus the bottom a minus 7. So what happens is that negative is going to have to distribute inside those parentheses there. So be very, very careful when you subtract because that negative is going to have to distribute inside an expression. So if I rewrote this, that's going to be 4a minus 2. And then to distribute the negative, that's going to be minus a. And then what was different than before is going to become plus 7 because a negative times a negative is a positive. Now you can clean that up by adding like terms. So 4a minus a is 3a. Negative 2 plus 7 is positive 5. And that is my final answer.